Hello and welcome to our third webinar on card sorting Part 3. I'm William Hudson and I'm going to be talking to you for about the next hour on some advanced analyses that we've developed for our SynCaps version 3 product. So in the first two webinars we've been talking in fairly general terms about card sorting. A lot of what we discussed is actually available in various online sorting packages and through our own SynCaps desktop software, Windows desktop software. But today is a little bit different because all of this is brand new. It's only available in SynCaps version 3, and we think it's going to make a big difference to the way that you work with your card sorting results and help a lot in making sense of card sorts, even card sorts that you've done in the past and you're maybe having trouble with or wished you'd done differently. We may be able to help you out with those. So today we're going to be looking at specifically SynCaps version 3, the new release of our software due out later in February, hopefully, if not certainly in March. It's not an operating system. There aren't hundreds of developers working on it, so we're not expecting any major delays on that front. This is where we are in the scheme of things. As I mentioned, this is the third, so we've done two already. So here we are on what am I talking about? February the 7th. If you need any information about what we've done so far or about any number of things to do with card sorting, you can visit our card sorting pages and this URL www.syncaps. And SynCaps, I think I explained in webinar number 1, stands for Syntam Computer Aided Paper Sorting. So computer aided paper sorting is what the CAPS is, and the Syn has just been stolen from the front of Syntam with the silent G, by the way. So that takes you into the card sorting pages in our website, and you will find there the recordings of and also the slides for the first two webinars. So if I just quickly click on that link, you'll see these are the various pages there and webinars and videos, and you will find that we have streaming and also downloadable videos for the first two sessions, and obviously the third session will follow there very soon. Resources I've mentioned in the two earlier webinars, and I will do so again just for completeness. There is an article that I wrote for Interactions magazine, which you can get from our website, and a much more elaborate discussion on card sorting, covering some of the stuff that we're not going to talk about today simply through lack of time, but for example, how cluster analysis works in detail. That's available at the Interaction Design Encyclopedia, and you can either just type those words into Google with the words card sorting following, or you can follow this link. We do have these presentations I already told you about, including some short videos on how to do paper sorting, and you can find those on YouTube as well. So if you just type in CAPS card sorting into the YouTube search or follow this link, then you will end up with those four relatively short videos. If you'd like a little bit more detail and some actual hands-on experience of card sorting, I will be presenting my half-day card sorting course at the CHI conference. I've been running it about every year for the last 5 at CHI, and CHI this year is in Europe, so it'll be in Paris, and the course will be on the 30th of April from 2 o'clock to 5:20. There's also our Gorilla UCD webinar. We have a series of 16 of these 90-minute webinars. Webinar number 7 is about card sorting in general, both online and paper sorting. It's not specific to SynCaps, and again that does go into more detail about some of the background theory on things like cluster analysis and so on. A little bit about SynCaps version 3. It will be a free upgrade from version 2, so if you're already a version 2 user, or if you are thinking that you'd like to get version 3 at the version 2 price, then that will be very straightforward. The version 2 price is currently €180. £150 or 240 US dollars, and you can choose to be billed in any of those currencies when you download and install the software. You click on the Buy Now button and you get a page which lets you make that decision. The software is actually Windows-based. It runs on Windows XP and later, and you can run it in a Windows emulator in the Mac. It's just way too specialized to actually have a Mac version and a Linux version and so forth. There just aren't enough users in the whole world to make that a sensible investment of effort, I'm afraid. So if you do want to run SynCaps, you need to run it on a Windows machine or in a Windows emulator. There is a comparison table. I'll briefly show you. I've done a bit.ly link here, bit.ly/syncaps-compare, and that shows you version 1 versus version 2 versus version 3. Version 1 is our free version, so that's there, and you can try that out. It produces the dendrogram that I'll be showing you a bit later on, and a handful of spreadsheet tables. Version 2 a little bit more elaborate, as you can see from this middle column, and then version 3 adds all this this new material shown at the bottom of the table. Version 2 will be going away when version 3 comes out, so as I said, you'll be able to, if you are a version 2 user, you'll be able to upgrade for free. And just a technical point on the pricing, and that is that in the UK we have to add 20% VAT, and that's also true for anyone ordering from the EU who doesn't have a VAT number. The pricing for SynCaps version 3 is currently planned to be a bit more than version 2. It's going to be €240, £200, or 320 US dollars. So like I said, if you actually fancy the idea of getting version 3 when it comes out but prefer the version 2 prices, then do think about getting hold of version 2 sooner rather than later. Questions, as usual, if you're watching the live webinar, then you can use the GoToWebinar question interface, and it's a sort of a chat. You type in the questions and I will read them out and answer them during the webinar. If you're watching the recording, or the questions only occur to you after the end of the webinar, which often happens to me, then do please email me at william.hudson@syntam with a silent G, syntagm.co.uk. And there's also an email news/discussion list you can join just by sending an empty email to caps-subscribe@mailman.syntam.co.uk. This is what we're going to be talking about, and as per the earlier two sessions, it's going to be about 30 to 40 minutes of the prepared presentation, followed by about 10 or 15 minutes of demonstration, and then time for questions at the end. Do feel free to ask questions as we're going along. I'll stop occasionally to address those. Of course, since we're talking about a whole bunch of new stuff, I may not be presenting it as clearly as I should be. You know, if you've got your head really stuck into a problem and you've been dealing with it on a day-to-day basis for a long time, then sometimes you actually forget to explain very important things. I hope I haven't done that, but if I have, then do feel free to pick me up on it or to ask questions where I haven't perhaps gone into enough detail. So I'm going to start by introducing this whole idea of participant analysis, and then using these things that we've introduced to SynCaps version 3 called participant filters. As I mentioned, the participant analysis will actually result in a couple of different filters. So we have something called similarity filters, and then we have participant cluster filters, and we'll be looking at both of those in about 20 minutes or so. And then how to, in the software, look at the different kinds of results you get out from using these different filters and deciding what you want to do with those results, and how to proceed from there. And then eventually, or when you've chosen what it is that you're interested in, you decide, well, this particular cluster of participants looks most useful to me. You can then create a new data file with just those participants in it, and I'll show you how that's done in the software very briefly. The reason for the participant analysis, and I've been doing card sorting now for I think something like 10 years, and it never ceases to amaze me how confused some people can be, or how confusing they can be in how they sort things, and you end up scratching your head and wondering, why did they do that? Or they really didn't understand what it was we wanted them to do. So there are a whole bunch of reasons for that, and I'm not really trying to blame the participants at all. In many cases, it's us. We've not briefed participants very well, or we've got unreasonable expectations of our participants, or we're just being too optimistic about how they understand the problem, or their ability to see the problem from a general user's perspective. So I've got a list here. Reasons why people don't produce the kinds of results that we would ideally like. Maybe they're just not good at systemizing. That's number one. That not everybody who actually uses websites and desktop software or what have you is actually good at describing how they think it ought to be organized. So these people may simply produce poor sorting results, poor when compared, say, to other participants who perhaps have done a better job, or poor to what we were expecting. And so they may end up creating a fairly muddy result for us in terms of the cluster analysis and the various other analyses that we do when we're looking at the card sorting results. They may not be adequately familiar with the items that they're sorting, and this is, again, possibly down to us being a little bit optimistic. That I certainly have seen people engaging with a large number of participants on something like an intranet design. And in many cases, there will be participants who've never actually used the intranet or use it very rarely. So to them, a lot of the terminology, a lot of what we're asking them to sort is absolute gobbledygook. And not surprisingly, they produce results which look like they think it's absolute gobbledygook. So again, we get poor result out of that. Some people will sort the items differently because of their tasks, their job roles, or the way that they need to do their work, and so they come up with a different set of results to other people doing the same sorts. And again, that does produce muddy results. And of course, they may be using the interactive system, whatever it is, in a different context of use, or a different set of contexts of use. So that can also produce differing results. And then finally, a little bit of a catch-all. They're not fully engaged with providing useful solutions, and that can, again, be for a whole host of reasons. They may not be terribly well motivated. You might actually be doing an online sort with a panel, and I'm afraid that my view of panels is not terribly good, having used them on a number of occasions and had a real range of results where people clearly have been in and out of the task as quickly as possible just to get credit for having done it. And you can see that in the analyses, and happily with the participant analysis that we're going to be looking at now, we can actually exclude people who have done things in a very different way, or split them off into a different cluster, that kind of thing. So this is what we're talking about doing with the cluster analysis, is actually trying to account for people who have done things in a very different way, or perhaps have done things in haste in a very unusual way, and try to actually either remove them or set them to one side, put them in a different cluster, so that we can actually look at what are to us more useful results for informing the design of our interactive system. So what I'm going to do in talking about participant analysis is just briefly back up and look at what we would refer to as traditional card sorting item analysis, which is all to do with how often pairs of items appear together in groups. That's how the cluster analysis is done, for example. It's all about how often any particular pair of cards is actually appearing in the same groups. And that allows us to build something that some people call a proximity matrix, other people call them a similarity matrix. So they are the same thing. And I'll just quickly show you some examples of that. So this is an example I use in my card sorting course, and it's just a really simple wine example. So we've got dry white wines, or we have actually wines that don't quite fit in these categories, by the way. So some of these are not dry white, but they are white wines. But anyway, that's part of the complication of this particular example. But in this particular case, we have three groups labeled dry white, full-bodied red, and sparkling. And these are the answers that we would expect people to provide. And let us assume that a participant has done exactly that. And we end up with this thing called a proximity matrix or a similarity matrix for one participant, which simply has in it effectively a tick for every time that pair of cards appears together in the same group. So starting in the top left-hand corner, Beaujolais and Cabernet Sauvignon appear in the same group because they're both red wines. A bit further down, Champagne and Cava appear in the same group because they're both sparkling wines. But if you actually follow the Champagne line across, you'll see that nothing else is actually grouped with Champagne, because it turns out that there are in fact only two sparkling wines in this whole collection. And then further down we've got Syrah, also called what? I've forgotten the Australian name for it. There is an Australian name for Shiraz, that's it. Syrah and Shiraz are the same grape, but Syrah is the French name for it. So, as I mentioned, we do this for every single pair that appears together, and this allows us to produce an overall matrix for all of the participants in our sort. In this particular case, we have precisely 12 participants, and all we've done is added up the various proximity matrices for all of those 12 different sets of sort results. And we can see the highs and lows. The lows are these empty matrices, these empty cells, I should say. So for example, there would be a 0 in here, but it's actually easier to spot when it's empty. So Beaujolais and Chardonnay were not sorted together by anybody. So that's good news, because they recognize that Beaujolais is a red wine, Chardonnay is a white wine, and so they've not put that together. At the other extreme, the best scores we've got are down here in the bottom right. And bear in mind, this is a matrix, so the diagonal runs up the middle here, and the whole thing is mirrored. You could just fold this matrix over, and it would be exactly the same. So you'll notice the pairs running down the diagonal, 2 and 2, 2 and 2, 6 and 6, 5 and 5, and so forth. So everything you can find in the bottom left is also in the top right. But what we've got here is a 12 and a 12, and therefore the same pairs, White Zinfandel and Riesling. And they're both 12 because everybody recognized those as being white wines and put them in the same group. So that's how the proximity or the similarity matrix works. And the point of going through all that is that we can actually do exactly the same thing with our participants, as it turns out. So this is what we produce from the proximity matrix. It's what's called a dendrogram. And you'll notice that the pair that I said was the most popular, I'm just going to step back a slide. So that's down here, the bottom right, White Zinfandel and Riesling. White Zinfandel and Riesling has the strongest relationship in this dendrogram. So the short branches, just like in real trees, are the strongest. And the weakest relationship is actually within the groups is between Pinot Grigio and the rest of the white wines. And again, if I just back up one slide, we look at Pinot Grigio, and we see that it hasn't really got a very strong relationship with anything. Given that 12 is the maximum, the best it manages is a 7 with White Zinfandel. So it gets tagged on to the end of that particular group. So this is something called agglomerative hierarchical cluster analysis, and it's a very typical, or it's a very common way of dealing with this kind of analysis problem, card sorting, and it's very reliable. There's no magic to it. In my course, I actually tell you how to do this by hand if you wish to. Computers are very good at it, and it will always be the same, no matter who does it. The only slight variations I should mention is that under some circumstances where an item could go into one group or the other because it has an exactly equal score, the choice will be arbitrary. So you might find one piece of software that puts that particular item into one group, another piece of software puts it into the other group. But that will be a very weak relationship in any event, so it's not going to be a terribly important one. But like I said, we can actually do the same thing with participants. Only with participants, what we actually do is to measure how similar the participants are in the way that they've sorted the cards. So if I take a set of 100 items and I sort it, and you coincidentally sort those 100 items exactly the same way that I did, then you and I would be 100% similar in the way that we sorted those cards. And the way that we calculate this similarity is that for every card that we have to move from my solution to make it look the same as your solution, that actually reduces the similarity score. So if we talk about 100 cards, because we do this in percentages, so it's 100% is a very easy number to deal with in that case. If we have to move one card in my solution to make it look like your solution, then we are 99% similar. If we have to move two cards in my solution to make it look like your solution, then that makes us 98% similar, and so on down the scale. Similarity scores of 70 and 80% are actually fairly common. You'll see in some of the analysis that we're going to look at that we do get much lower similarity scores than that, but for reasons that we'll go into. So this is the big difference between the participant analysis and the item analysis. The participant analysis is based on how similarly the participants have sorted the set of items. And here is what we would call a proximity or a similarity matrix. And again, I mentioned already these are percentages. And this is actually from test data that we've generated, where one set of participants, and these are the participants that actually start P1, the test generator just numbers them like that, have sorted the items using 7 groups, and the participants starting P2 have sorted the items using 13 groups. So not surprisingly, we get a lot of similarity, and this is a random element, by the way. About 10% of all of the cards have been randomly sorted. So every 10 cards, we would just put it into a random group rather than putting it where it should go. So that's why, and that's much more realistic when compared to people sorting. So we haven't actually produced exact solutions. We've randomized them somewhat. But what we've got at the top left-hand corner here is participant 1.3 and participant 1.5 being 98% similar in the way that they've sorted that particular set of cards. And at the other extreme in that participant 1 set, we've got 74 down here. So that's still fairly strong. I mentioned the typical score is in the 70 or 80. So this green block, and all I did, by the way, is I took the proximity matrix that SynCaps produces for participants. SynCaps version 3 produces this for participants. SynCaps versions 1 and 2 only produces this for items, but it's the same idea. And then in Excel, I just asked it to color code according to the values. So this is straight out of Excel. It took all of a minute or 2 minutes to do this. But we can see that what we've got, again, bearing in mind that everything above the diagonal is exactly the same as everything below the diagonal. But what we've got here is a big chunk of very similar results. And then down here, when we look at the relationship between the P1s and the P2s, we've got a big chunk of not very similar results. So all of these results are in the teens or low to mid-20s. So we've got, for example, 14 in this chunk as the, I think, the lowest score, and then 24 is the highest score. So this is showing us that we actually have a fairly clear separation between these two different sets of 10 participants. Again, because this is test data, it looks very extreme, but I'm going to walk through this particular example in the slides, and I'm going to show you a real-life example with real participants, which will be a little bit less clear, but just as useful, hopefully. So this is our proximity matrix for the participants, and what SynCaps version 3 produces is not only an item dendrogram, which would be shown on this tab, which would, I'll show you that a bit later on, but also something called a participant dendrogram. And this participant dendrogram is showing us how similar the participants were in how they sorted these items. And what you'll notice is that it's very obvious that they sorted, that there were two different sets of solutions here. And that's one of the things that SimCaps version 3 is designed to do, is to show you when you have participants who are doing things in a substantially different way. Now, in a real sort, it's not usually quite as obvious as this, but I will show you what we get out of a real sort, and you'll see that it is still fairly obvious in many instances. So in SimCaps version 3, we introduced two kinds of participant filters based on participant similarity. The first one is simply called a similarity filter, and you can say that somebody who isn't at least this similar to someone else in the results, I just don't want to include. So if, for example, you ended up with a handful of participants who did it like no one else, so their similarity was, say, 50 or 60% or lower, that's their maximum similarity. So they just didn't do it like anyone else in the whole collection of participants. Then you could say, well, I would rather exclude them from the results and see how much that improves the results. And chances are it will improve the results fairly noticeably if you've got a fair few people like that. But the other filter is actually based on doing a cluster analysis on that similarity matrix that we just saw. So just backing up again, here we can actually see from the dendrogram that there are clearly two separate clusters. Sometimes it's not as clear as that. So we actually do a separate cluster analysis, and we use techniques from the field of bioengineering and genetics to calculate the number of clusters and to decide whether there are significant clusters in your participants. You may look at that dendrogram for the participants and decide, well, I'm not really sure, or it's not clear to me. The software will actually go and do a test and tell you whether you actually have significant separate clusters of participants in your population. And that may be because you've asked different groups of people. One of the really large sorts I did fairly recently for a global insurance company had us using 450 participants from all around the world. And of course, it's not impossible that participants in North America may well have sorted the results separately from participants, English-speaking participants in Europe. Or of course, we could have done the sorting in different languages too. We might have found that French speakers sorted these items differently to Spanish speakers. So all of these things become possible just by looking at the results, not by actually taking into account anything specific about the demographics of the population. And we can create any number of filters and select them in the main window to see what that particular population looks like in terms of its overall results. Now, this is the filtered by participant similarities dialog, and this rather scary-looking diagram at the top is actually fairly straightforward when you get used to it. This is actually just a count of all the distributions that we saw in that proximity matrix. So if you remember me saying we had figures that were in the teens and low 20s, this 20 column actually represents everything up to 20. The 30 column represents everything up to 30. So this is a count of how many different cells in that proximity matrix had those particular values. Now that is actually a bit unusual, that we have up this end some very high scores, and the bar is actually showing us the maximum similarity between participants. And if this maximum similarity and the bar chart underneath it actually coincide like they do here, then that shows you that you probably only have one cluster. But in fact, these down here mean that something else is going on, that we've got something like multiple clusters. And you don't have to guess at this, but this is actually just an indication that you might want to go and do participant cluster analysis using this particular interface shown at the bottom here. But this is where we start. This is the participant similarity filter, and you could, if you wish, type in a similarity into this box, and it would tell you how many participants would qualify with that similarity. And if you like that figure, then you can just say add it to the filters, and it will omit the participants who don't have that minimum similarity. So that's the similarity filter. The second filter is the cluster filter, and to do this, what we show in the chart is a variety of solutions. Now, in this particular case, the software's only been able to find 2 clusters in this test data set, which isn't too surprising because it's a test data set and it's very clearly only got 2 clusters in it. Ironically, if it was a more randomized set of data, if it was from real people, it may well find solutions for 3 clusters, 4 clusters, and 5 clusters. And you will see that in large data sets with lots of different people doing lots of different things. But in a small data set like this, which is, say, was machine generated, it's only actually been able to find a 2 cluster solution at best. By default, SynCaps version 3 will try to find up to 5 cluster solutions. But just because it's found them doesn't mean they're significant. So in fact, this is showing you something called the dispersion between the clusters, or within the clusters, I should say. And the dispersion is just a measure of how scattered the results were. So lower dispersion is a better result. And you can see the dispersion actually jump from about 16,000 when there's only 1 cluster down to nearly 0, about, well, something like 2,000, 3,000. So that is quite a dramatic drop, and that would be indicative of you having 2 clusters. But you don't have to guess. There is a button down here, which I'll show you on the next slide, labeled calculate the number of clusters, and it tells you this is going to take less than a minute, and it will go away and sort the cards randomly 10 times and come up with the dispersions averaged out across those 10 trials and give you those as a comparison. When I say give you those, it actually uses that as a comparison to decide how many clusters there are. So you end up with the following screenshot. And so now we have the expected, which is from the random trials, and using that we can see that there is indeed a huge drop in the observed dispersion relative to the expected dispersion, and there would have been a little pop-up message box saying we found 2 clusters, but you also see that on the screen now we've got that there are 2 clusters. And what we can do in SynCaps v3 is go back to the main window and now choose which of the filters we'd like to use. So we've got the unfiltered choice, which is always there for our 20 participants, and then we've got 2 separate cluster filters, the filter for cluster 1 and the filter for cluster 2. And we can put these side by side using an interface which is virtually identical to the one used throughout Microsoft Office, which regrettably is a little bit complicated and hidden, but it's the one that's been there for 10 or 15 years. It's changed a little bit when Microsoft moved to the ribbon interface in Office 2007. But what you do is you go to the View tab, you create a new window, and then you can tile the windows. You can put them side by side. And this new window is a different view onto the same document. And in the 2 different views, you can select different filters. And so that looks like, well, I'll show you. This is what it looks like before we've created the 2 different views. So this is the before scene. And you may remember from our earlier webinars that this actually would be a very discouraging result if you got this as a result of a cluster analysis. But note, by the way, there aren't any item names here because this is test data. The items are just numbered. They're not named. These should be item names down the diagonal. But we've got a lot of noise in the body of the table. If you recall the way that these item by item or similarity charts work, what we want is lots of dark colors in the diagonal and nothing, preferably, in the rectangular areas in the body of the chart. So we should have just a series of steps running down the diagonal. That would be an ideal solution, but we've got anything but that. And of course the reason for that is that we've got two completely different sets of results. We have one set of participants who've sorted the cards into what did I say, 7 groups, I think it was, and another set of participants who sorted the cards into 13 groups. So what I'm going to show you now is actually having done the participant cluster analysis, I'm going to show you them split into their 2 groups. So we've created the 2 windows, and that's what this colon 1 and colon 2 up here means, by the way, that this is window 1 onto the same document. And you can do this in Word and Excel, and I don't know if you can do it in PowerPoint, but it's the same interface throughout Microsoft Office. As I say, it's a bit weird and a bit well hidden, but once you know it's there, it works pretty consistently throughout those applications. And so window 1 here is set to look at cluster number 1, and that is the 7 group solution. And window 2, and it's the current window, it's got a slightly darker title bar, and that actually means that the information up here shows us which filter is selected for this particular window, is the 13 group solution. And so we've actually been able to do a cluster analysis, find all the participants in these 2 different solutions, and then separate them out. Now, as I say, this is a completely artificial test data, set of test data, but what I'm going to show you in the demonstration is applying exactly the same principle to a real scenario, a real sort that I ran a little over a year ago. But before I do that, let me just show you that what you can do, as well as looking at the solutions in the different solutions in SynCaps like this, you can use a save filtered dialog in SynCaps to output separate files for each of these solutions. So you can create, I've selected both separate clusters here, so this will actually create 2 separate data files now, one for cluster number 1, one for cluster number 2, and if you wish to, you could re-import those into SynCaps as if they were completely different sort results. Now, one thing I'd just like to mention is that if you have had problems with getting sensible results from a card sort, and you think that this kind of participant analysis might help you, then do please get in touch. We could have a quick run through SynCaps version 3 with it and give you some useful results back. The only proviso, well, there are 2 provisos. One is that you would need to agree to allow us to use the results in training or in promotion. If you needed to, you could go through and anonymize the data, or ask us to anonymize the data, whatever you think is necessary, so that the original problem domain or customer can't be identified, but that's entirely up to you. And the other proviso is that we're not offering to do this for everyone forever. So if you think you might benefit from this, we'd be certainly willing to have a go for you, but I can't guarantee that we will be doing this for the rest of eternity, for example. That almost certainly is true. But do get in touch. Let us know if you've got some data that you think might benefit from this kind of analysis, and we'll find out whether it would. Now, what I'll do, I'll tell you about the questions, because some may come up whilst I'm doing the demonstration, or you may already have some that you'd like to ask. So do make use of the GoToWebinar question interface if you're watching the live webinar. If you're watching the recording, then email me with any questions. I'd be happy to answer those and get back to you. But what I'll do now is stop in the presentation and go and do a live demo. So here we are, SynCaps version 3. And what I have is an online sort that I did a little over a year ago, and you actually may have participated in this sort if you're on one of my mailing lists. I invited a large number of people from various user experience and usability news lists to take take part in a sort of fruit and veg produce, I've called it here. So this is just under 100 participants, so I think the figure is actually 96. And the participants were requested to sort the data in one of two ways, simply to add, excuse me, a little bit of variation. So, excuse me, people born in a, I can't remember exactly which way around it was, people born in an odd year were asked to sort the data and introduce a group called green vegetables. And people born in an even year, and as I say, it may be the other way around, were asked to introduce a group called salad vegetables. Now, it's absolutely amazing how many people found this very difficult or complained that they just didn't think about fruit and vegetables that way. I didn't make these up. These are actually from local UK supermarkets. So whether this is just a particularly British way of looking at produce, I don't know. But I can walk down to my local supermarket, which is about 5 minutes down the road here, and they have a salad vegetable section. And I can go to a supermarket on the edge of town, and they've got a green vegetable section. And so this wasn't me just creating awkward groups for people to use. They do really exist, but it is amazing to see how that's affected the overall results. So here we go through the analysis, and one feature we've added to version 3, since we have got this participant dendrogram, the data as it came from the online sort actually has email addresses for every participant. We don't want to show that in the charts. So what we do is we tick the box that says anonymize participants in charts. The data files still have the original email addresses in it. So if you want to find out who participant number 32 is, you just go and look at the participant spreadsheet and it'll tell you. But in the charts, if you might be sharing with colleagues, or you might be sharing with clients even, you don't actually get to see who the participants really are. So let's go and do this analysis. This has said 94 participants. I misremembered. I thought it was 96. And there are 35 items. Now, one thing I've already done here is taken a lot of the variations. Like, for example, here we have, this column is slightly too narrow. So let me just, M means merge. So I've created a group that I've called citrus. And in that, I've got 36 different participants' use of the term. So I've got 8 that use the word citrus with a capital C, 1 that used the word citrus with a lowercase c, 11 that used citrus fruit with capital letters on both, 6 that used citrus fruit with only 1 cap, and so on and so forth. So this is merging these groups together makes the results more meaningful, and you'll find lots of other examples of that. So for example, cabbage family, various spellings and variations, cabbage family vegetables, cabbage underscore family, etc. So I've already done a fair bit of that, and this is how I do recommend that you simplify your data, is by merging these groups in this particular interface. I wouldn't suggest you actually edit the data, and you will find interfaces like this, just like this, in most of the online sorting packages too. And it doesn't matter whether you do it in the online sort or once you've downloaded the data. The slight advantage of leaving it until you've downloaded the data is that it means that you can change your mind on the desktop quite easily. You can adjust it, and you have all the original data still, as opposed to having the massage data that the online package may have provided. You can do similar things with items. This is the merge items dialog. It looks almost exactly the same as the merge groups, as you'll notice. I can go back and show you. That's merge groups. This is merge items. This is useful for when you've invited participants to create new items. Now, you can't do this in online sort. So because this was an online sort, this will not show any merging unless I decide that, oops, these two items are so similar that we shouldn't have made them separate items. They should have been considered together, in which case I could merge those. So for example, if I had courgettes and zucchini as separate items, I could decide, well, actually, these are just different names for the same thing, so we shouldn't have made those two separate items. We should merge those into a new group, and we could do that here if we wish to. And here now on the final step, we're being shown all of the different spreadsheet files that SynCaps is going to produce. And if you tick this box underneath, it will actually open up all of these in whatever application is associated with all these .csvs, and usually that's Excel. You'll also notice that in SynCaps v3 we produce some script files for SPSS. So that's what these two lines are for here, and it will try to open these in SPSS. The only downside to immediately trying to open this in SPSS is that if you've used any funny punctuation in your item names, then you may need to edit these scripts before you try opening SPSS. You might get errors from SPSS because it doesn't like punctuation in item names. Certainly, in variable names. Certainly, it never used to. But I generally don't recommend ticking that box because you end up with all of these spreadsheets opened all over your desktop, and it's a bit overwhelming. But you can do. It's not a big problem. So I'll click Finish. It's about 100 participants, 35 items. I think it takes 5 or 10 seconds to process that. This little warning message is telling us that this particular participant, whose name I should be obscuring, but this normally wouldn't occur, has two groups that we've merged together. So I'm just going to continue past that. I don't really mind that because I merged some groups and they use both. So here we are with the general result, and you'll see that we have on average, 7 groups used by participants. I can just kind of hold down Control and hit the minus button to reduce the text, the font size somewhat. You can do that over here with smaller chart, and you can also do that in the charts ribbon to reduce the font size. And when you reduce the font size, the whole chart shrinks with it. So that's the whole thing. It's looking a little bit muddy. This is what I refer to as muddy. As I mentioned before, ideally in these item by item, I call it a pairs map in SynCaps version 2. Other online packages now produce these two in pretty much the same format since I introduced it in SynCaps version 2. And they call them similarity matrices, and all of those are perfectly sensible names, and I can't really argue with that. I think items by items fits better with what else I'm showing on the screen here. But you should have nice, clean, diagonal groups like this, or groups on the diagonal, where we move down into potatoes through carrots. We've got a lot of noise underneath. So this is showing us that we've got a lot of people who have sorted it differently to this. So this is the best solution with the one set of participants we have. Potatoes, sweet potatoes, swede, turnips, parsnips, and carrots. But some people also lumped in, say, ginger, for example. Not so much chilies. You'll notice that chilies is not generally grouped with these guys. But fennel, bulb fennel, 22% of participants put bulb fennel with swede and rutabaga, for example, and so forth. So as we get further down the chart, we get even more muddiness. And in fact, this is a feature of all 3 versions of SynCaps, that the strongest results are usually at the top of the chart or at the top of the group, and the weaker results are at the bottom of the group or the bottom of the chart. So that's where we start. Now what I'm going to do is just show you the filters. So here's the 3-step process if you follow it through. We've already done the import-export. The second step is to look at participant filters. And the fact that we've got some very strong maximum similarity here. 55 of our 94 participants have a similarity of 80%, is good. But the fact that it comes along with a lot of participant pairs down here in the 40 and the 50 suggests there's something funny going on. So I'm not going to create a similarity filter. I could do. I'll do that just to show you what it looks like. So the average maximum similarity is about 76. So if I were to type 80 into this box, that would include a little bit less than half of all the participants. So let's not be quite so rash. Let's make it 75. 75% minimum similarity gets us 54 participants, a little bit more than half, and we could just add that to our filters. If we click on Manage Filters, we'll see that that's now in there. But what I want to do now is actually do a participant cluster analysis. So Syncaps v3 has been able to find 3 potential solutions, the 1-cluster solution, which will always be there, the 2-cluster solution, and a 3-cluster solution. It tried but failed to find a 4- and 5-cluster solution. And of course, we don't know exactly which of these solutions is significant from a statistical point of view. Usually a sharp drop, the first sharp drop, is actually the, sometimes called the elbow, is the significant piece of information to look for. But like I said, you don't actually have to guess. You can guess if you like. You can actually go into manual and just say, I want to see the 3-cluster solution. But if you stay in automatic, which is what we recommend, you just click on the calculate number of clusters, and this takes a little bit of, no, it doesn't take very much time. I'm used to running this in debug mode, which is about 10 times slower, and in debug mode it takes 10 or 15 seconds, but that was pretty much instantaneous. So you'll notice, by the way, in the background that we have now the expected results. And so this is from the 10 random trials that it's done. And what it's telling us here is that it's found that the 2-cluster solution is the best one. So let's just say, yes, we want to add them to our filter list. And now if we look at Manage Filters, we see we have 3 filters. We have the simple similarity of 75% filter, and we've also got these 2 cluster filters, and we can go and play with those now. So what I'll do is I'll close all these, and so we could just go and look at any one of these now. So if I just clicked on the drop down and selected the 75% similarity as a minimum, so this loses us almost half of our participants. So N goes from 94 down to 54. Bear in mind that at the moment we have 7 groups in our solution. Let's see what happens when we go for this particular one. It stays at 7, but you may have seen that it changed slightly. I'll go back and do that again. So that's the unfiltered solution, and here's the filtered solution. Not a huge change. I think I saw some of these change order, but the number of items didn't change. So it's not a significantly different solution, even though we've thrown away almost half of the participants. But let's have a look. And what I'm going to do for this is to create this second view, as I mentioned. So as I mentioned, you can do this in Microsoft Word as well. You create a new window, and it's called a new window because it's a new view onto the same document. And that's shown by these numbers following the title. So this is view number 2, :2. And what it's done, because it's full screen, the window, it's hidden window number 1. So I'll just click on Tile Windows, and that'll put the 2 side by side. And what I'll do now is I'll go back to Home, which gives me my participant filter. And this current window on the left-hand side, I'll select cluster number 1. And that, by the way, now is a 9-group solution. And I'll go over here and select, this is the unfiltered solution here, but I'm going to select cluster number 2, which is a 5-group solution. And what I'll do is just reduce the chart size a little to get it all onto the screen, or most of it onto the screen, just to show you the shape of things here. And what you can see is that although I asked people to introduce these 2 specific groups, green vegetables or salad vegetables, when I actually look at the list of group names, it's not like they paid a great deal of attention to that, to be honest. But for whatever reason, we actually have a significant number of people who went for a more refined solution. They went for more clusters. So here on the left-hand side, as I mentioned already, we have a 9-group solution, and here on the right-hand side we have a 5-group solution. And one of the big differences you might notice from this is that in the 9-group solution, we actually have all the citrus fruit up here as a separate cluster. A little bit of disagreement, though, over that. So, you know, a lot of people wanted to put grapes with citrus fruit. So that is 29% of participants wanted to put grapes with citrus fruit. But we have quite a clean solution for the rest of the fruit. And in fact, we have a clean solution, and when I say clean, I mean not muddy. It's most of the body of the table is actually clear underneath for fruit. So not a lot of people actually happily wanted to sort fruit with vegetables. Some did, not many. Here we have oranges sorted with tomatoes, and some people actually took the view that tomatoes are really fruit, which of course, botanically speaking, they are, but that's not really what we were asking them to do. But here you have it, 2 statistically significant different groups of participants. And this happens in real life. This particular one was set up artificially, although I'm not sure I actually got what I expected. I got a much more refined versus a much coarser solution. But I have seen results like this in other data that I've run through SynCaps version 3. I've seen little clusters of participants who have decided that they're doing it differently for whatever reason, and you can now find those and have a look and see what they're doing. And if you don't anonymize the results, you can actually see who's doing it. So if we turn these both to the participant dendrograms, you get just the participants who contributed to this particular solution. And because I've got anonymized participants turned on, all that we get here are participant numbers. But if you didn't have it on, then you'd actually get names or email addresses or participant IDs from the online sort. So you'd be able to make some educated guesses, or you'd be able to tie that up with some other research that you've done to show the demographics behind some of these participants. I can just make these a little bit smaller. Not working. Smaller chart. Come on, you can do it. There we go. So by the way, these stragglers down here, we could get rid of these by applying the similarity filter first. These guys on this side as well. These are the weaker relationships down here. The strongest ones are up here with P1 and P27. They did things in a fairly similar way. P20, P51 over on this group. So we've got the items by items for these guys. We also have the items by groups, and these will all be different according to the participants in these 2 particular filtered sets. So that's the end of my presentation. I see we have got a question, so let me just find out. Yes, okay. The question is, does SynCaps 3 include multi-level sorting? And admittedly, I haven't talked about that today. I talked about that in session 2. So if you go and visit the syncaps.com page and look at the webinars, I do talk about multi-level sorting. But yes, SynCaps version 3 does support multi-level sorting. The only thing I have to say about that is that currently no online sort solutions that I'm aware of actually support multi-level sorting. So you have to do multi-level sorting with paper cards. It's not a big problem. It's not a big difference from, or not a big change, I should say, if I was going to use English a bit more grammatically. Not a big change from how you might do SynCaps sorting normally, but we have a slightly more sophisticated group card which has levels on it. You can actually, in theory, go up to 9 levels, but the group card that we supply with the templates has barcodes up to 4, so people can just tick a box, and then when you're doing the processing of the cards, you can just scan the barcode that corresponds to the tick. But you could similarly, or just as easily, write in the level number. But I talked about that in session number 2 if you want to find out more about that. Any other questions? The recording and the slides will be available on the website tomorrow probably. That's the 8th of February. And you'll get some reminders from both GoToWebinar and from me about that. But if you're watching the recording, you've already found it, so you don't need that information. So thank you very much for listening. That's the end of this particular set of free webinars on card sorting. The recordings will be there. We may run others in the future. If you join our mailing list, either of our mailing lists, there's the CAPS one I've mentioned. There's also a UCD mailing list you'll find on our website. Then we'll let you know. Thanks very much for listening, and goodbye.